Okay, so here's my hardware implementation of my read-only memory that displays the 7-bit ASCII code for each character in a 6-letter word. Now the word that I chose to use was endure, with all capital letters. And since there are 8 possible addresses when using a 3 to 8 decoder, I also chose to add 2 underscores as my last 2 characters. Now the address bits that I used were input 0, input 1, and input 2 on the digital evaluation board, with input 0 being my most significant bit into my decoder and input 2 being my least significant bit. I displayed the ASCII bit outputs on output terminals 0 through 6, with output 0 corresponding to the first ASCII bit, output 1 corresponding to the next ASCII bit, and output 6 corresponding to the last ASCII bit. While ideally this circuit could be easily realized by simply using multiple input NAND gates to connect decoder outputs to the ASCII bits, my hardware limitations forced me to be creative in using De Morgan's theorem and frequent inversion to make logically equivalent circuits. Nonetheless, here's my demonstration beginning with input address 000 corresponding to letter capital E with a 7-bit ASCII output of 1000101. So if I power on my circuit and keep all inputs low such that our input address is 000, we can see the 7-bit ASCII combination to be 1000101. Now when we go to our next address, which is 001 and corresponds to N, we can see the 7-bit ASCII code output to be 1001110. So let me turn on input 2 to high such that we have 001 as our address. We can see the 7-bit ASCII output to be 1001110. Now for the next address 010 corresponding to D, we can see the 7-bit ASCII output as 1000100. So if we turn off input 2, turn on input 1, such that we have 010, we can see our 7-bit ASCII output as 1000100. Now for our next address, which is 011 and corresponds to letter U, we can see the 7-bit ASCII output as 1010101. So if we simply turn input 2 back on, we get address 011, and our ASCII output is 1010101. Now for the next address, which is 100 and corresponds to the letter R, we can see the ASCII output as 1010010. So if we carefully turn off inputs 1 and 2, and turn on 0 such that we have 100 as our address, we see the output as 1010010. Now for address 101, which corresponds to the letter E, we can see the 7-bit ASCII output as 1000101. So when we turn on input 2, we have 101 as our address, and our 7-bit ASCII output as 1000101. Now for our last 2 addresses, 110 and 111, these correspond to the underscores, and both have the same 7-bit ASCII output of 1011111. So if we first test 110 as our input address, we see 1011111 is our ASCII output. And lastly, if we also turn on input 2 such that we have 111 as our address, we see the same ASCII output, 1011111. So that's my read-only memory circuit for the 6-letter word endure with underscores. And as you can see, each address combination matched the 7-bit ASCII output on the digital evaluation board.